Lesson 2-1. Before we get started on chapter 2, we're going to review 4 key topics from chapter 1. I threw these 3 problems. So here I want to note in a second, number 2, when I get to number 2, y'all with me? When I get to number 2, it says given f of x above, and you can see this on your packet. This f of x above, it's built off of the idea that this was on one sheet paper. That's going to be referring to this problem there, but I'll get to that moment when we get to number 2. But let's first do number 1. Number 1 says find the inverse of this function and state the inverse's domain. So this is one of the 4 key things you need to know from chapter 1. How do you find an inverse? Here, switch what? Switch x and y. It's very key that you know that. Inverses we will deal with throughout the whole year. You need to switch x and y. So f of x represents the y. So what we'll have is x equals 2 times y minus 3 squared plus 4. Now, algebraically, you switch x and y, then you solve for y. Those are really the 2 steps. Just how many steps is required to get y isolated can differ from problem to problem. On this particular problem, trying to isolate this y, whenever you isolate, you basically are going opposite of PEMDAS, opposite of the operations you see, because you're trying to solve for the y. So what should I do first here? Subtract 4, I agree. I'll subtract 4. Now, this is an equation, which means whenever we say an equation, both sides are equal. So if I'm going to keep it equal, because that's what I need to do mathematically, whatever operation I do on the right side of the equal sign, I need to do on the left side, just so it stays balanced, so it stays equal. So I now have x minus 4 equals 2 times the parentheses y minus 3 squared. Now, if you were listening, I gave away the answer a moment ago, but in case you weren't, this 2 is in front of this parenthesis. Mathematically, what is happening if a 2 is located in front of the parentheses? Multiplying, dividing, adding, subtracting, multiplying. So to solve for y, I need to isolate this y. How do I get rid of this? There we go. I divide by 2. And now when I simplify, I'm going to do something, I'm going to do something a little bit unique to most here. Division, again, it works the opposite of multiplication. And multiplication, we know, can distribute. Division also can distribute. And what I'm going to do here is to simplify this problem by thinking of a distribution on the division. So I'm going to leave the x being divided by 2. Can I simplify x divided by 2? Can x divided by 2 and give us a number or anything like that? No. Okay. I'm going to leave this as x divided by 2. But what I'm going to change is after the subtraction is I will simplify 4 divided by 2. What is 4 divided by 2? Yeah, so I will just kind of distribute that division through there, simplify. And so now we're left with the quantity y minus 3 being squared. Quantity meaning there's a group. What is the opposite of a square? Square root. So I'm going to add in a square root that was not originally there. No one wants to volunteer what I'm waiting for? Oh, good. Peyton, anytime you add a square root that's not originally there, what has to come with it? Plus or minus. Little known algebra rule, but very important. So now we have plus or minus the square root of x divided by 2 minus 2 equaling y minus 3. Last step to get y isolated. Y is being subtracted by 3. We'll add 3. Okay, so note this subtracting 3. Is that subtracting 3 inside a square root over on this side of the equation? No. So when I add 3, I'm not adding it inside a square root over here. Why do I point that out? If I want to keep this equation equal, when I add 3 to the left side, would I add the 3 inside the square root or outside the square root? Outside, because I have to keep it equal. since I'm adding 3 on the right side outside of a square root, then I need to add this 3 outside the square root. And so our answer, remember, once you get y by itself, you can rewrite it as f negative 1. That means the inverse is going to be represented by the equation plus or minus the square root of x divided by 2 minus 2 with the plus 3 on the outside of that square root. You could not simplify inside. You could not add that 3 with the negative 2 because that 3 is outside the square root. Otherwise, it wouldn't be equal. You wouldn't be adding the same number on both sides. All right. State the inverse of domain. By the way, let me pause here for a second. This inverse is one of those 4 important topics from chapter 1. 4 huge topics, inverse. A second major topic is domain. What do you assume the domain will be? All reals, until you see otherwise. Otherwise, it would be things like square roots and divisions. Do I have a square root here? Yes. Will you think my domain will still be all reals? I agree. It probably will not be all reals. So what I'm going to do here is I'm going to do a number line. And this number line, I start with the value 0. And I put a minus and a plus on either side. When you are dealing with the square root, the inside of the square root is not allowed to be a negative number. The inside of the square root is not allowed to be 0, or the inside of the square root is not allowed to be positive. Which of those 3 statements is true? It's not allowed to be negative, not allowed to be 0, or not allowed to be positive. A square root, the inside of the square root cannot be negative. It can be 0. It can also be positive. So this graph is going to begin at some value, which right now we're going to assume is 0, and go to the right. However, there are some transformations that have taken place. So I'm going to take that x minus 2, or excuse me, x divided by 2 minus 2, and say that value in there, that inside the square root, has to be greater than or equal to 0. It cannot be negative. That's another way of translating that. And we'll just isolate the x to get our domain. So one more time, let's do some algebra. How do I get x by itself here? Plus 2. So we just discovered that 0 is no longer that number. We now think it's 2, but we're still not done. X over 2 has got to be greater than or equal to 2. We need to multiply. Multiply by what? 2. To isolate the x, we need to multiply by 2. And so we have x is greater than or equal to 4. Good. So if you graph this, you would determine that our domain here is x is greater than or equal to 4, which you could also write as bracket. Bracket being because it's equal to 4 going on to infinity, because you can be going from 4 to the right, 4 going to the greater numbers. So you could write the domain either way here. That would be your answer. That is a second topic that's extremely important you understand from chapter 1. Foundational level, inverses, domain. Let's take a look at number 2 now. So I was trying to explain on the first slide, as it says on number 2 on your packet, given f of x above. Well, you don't have f of x above on your packet. You did have it on number 1, and that's what equation I'm going to use. Is the f of x from number 1, which if I remember right, it was 2 parentheses x minus 3 squared plus 4. Is that what the equation was? Yeah. Okay, there's our equations. It says here's f, here's g, here's h. Find bracket f o g o h close bracket of x. What does that even mean? Substitute. This is your third topic from chapter 1 that you really need to know. This means to substitute. And what are we substituting? We're going to take the equation h and substitute it as g, and then that equation into f. So I'm going to write them out. F is 2 times x minus 3 squared plus 4. G is 3x minus 2. And h was x plus 1. I use stack technique when I do this. Okay, ultimately, here's what's happening. we're going to take h's equation and substitute it into the place of x on the equation above. That's kind of the technique here. So I'm going to take h's equation and I'm going to substitute it in for the x in the equation above. That's the idea. So though it didn't ask for it, GOH of x would equal, and remember with substitution, think athletics. When you in athletics, it's you're going to substitute. You're playing basketball and Michael Jordan shows up. All your teammates are going to be like, substitution. Mr. Voorhees is coming out. Michael Jordan is going in. Do I get to still stay in and play? I go to the bench. I'm going to stay on the bench in this scenario. So the idea is this x is removed. This x plus 1 replaces. So I have 3 times, instead of this parentheses, I'm going to add in here, instead of this x, it's going to change to x plus 1. And then we subtract 2. Now we could substitute that in above, but I will simplify it first just to make it easier. I have a number in front of a parentheses. What does that mean to do mathematically if you have a number in front of parentheses? Multiply. So I will distribute this through. 3 times x is 3x. 3 times 1 is plus 3. And now that I've distributed, I don't need the parentheses anymore. So I have a minus 2 on the outside. And I can combine those like terms. I hear 3x plus 1. I agree. I have positive 3 minus 2. That is plus 1. So that right there is G of H. So we're supposed to find f of G of H. That is G of H. That is H's equation substituted into G. Now that we found that, we're going to take this equation and substitute it into the x in F's equation. That's the idea. So we're going to take this 3x plus 1, and it's going to substitute only for the x. Only for that x. That's what I'm doing here. So that's going to go in right there, which means F OG OH will equal 2 times, we have a parentheses, part of the normal problem, and then the substitution here. So I'll do 3x plus 1. That's the substitution. Minus 3. Close your parentheses, square it, plus 4. I'm going to try one more time to simplify this. I have back-to-back parentheses. Some students don't know this. When you have back-to-back parentheses, some students think, well, let's just distribute the 2 that's from there. That's not how it works. An easier way to get rid of this parentheses is in between. If you put a 1 there, it's like there's one of those parentheses and you distribute the 1, you can actually get rid of this second parenthesis. And I think it makes the math easier. So I'm going to distribute the 1 through the first parentheses, which is going to leave me with 3x plus 1 minus this 3, square it, plus 4. That simplifies my problem. I can actually simplify one more time. I'm going to write the answer down here. Running out of space. I have a plus 1 and a minus 3. What is plus 1 and minus 3 going to reduce to become? Minus 2. Good. There's my solution. Talk to me about the domain. This is called a composition. This is that third topic I said that you need to know. Means composition. Composition means to substitute. That's what they call that. But let's now talk about domain. What do you assume the domain is? Would you still say it's all real numbers after looking at the equation? You see any division? You see any square roots? Guess what? It's all reals. Domain is all reals. Or you could say from negative infinity to positive infinity. All right, the last and the fourth problem, or third problem, sorry, last topic, number 3, will give us our fourth topic of the day. And I just realized I haven't opened up on Power School Learning. I'm going to go there. We're on chapter 2. If you're looking for where am I supposed to submit these answers on a packet that says 2-1, well, go to chapter 2. That's where you're going to submit these. So now I'm in chapter 2. You've shown up. You hopefully signed the attendance chart up at the front of the classroom. We're on number 3. We're doing the in-class. You can click that. And this will, yours will say start exam. I've already clicked it. This will get us to number 3 here. On number 3, whoops. The question's a little different. It says how many transformations are there? So I want to let you count up and think yourself, how many transformations occur? And then we'll talk about what they are. So the problem's given that g of x equals 3f x minus 2 plus 1. The answer choices are that there's either 1, 2, 3, or 4 transformations. So I want you to think through how many transformations do you see here? I'm going to do a countdown. I want to hear your answers. 5, 4, 3, 2, 1. There's 3 transformations here. Let's talk about what they are. Whoops. For transformations, they follow 2 rules. I'll put these over here. This is our 4th topic from chapter 1 that's extremely important for you to get down moving forward. Number 1, I called it HIVO. It's that horizontal occurs inside, vertical is outside. You could also say X is inside, Y is outside. You could think of it that way. And rule number 2, what was rule number 2? Inside lies, outside tells the truth. You could also think of inside meaning x's, that your x's lie, and that your y's tell the truth. You could also think of it that way. And so going through these transformations, tell me the 3 here, inside or outside? It's outside. So if it's outside, it is vertical. If you're taking a test, they would say something about vertical. Next, when you multiply a number, does it slide it or does it shrink it? It's either a stretch or a shrink. It comes down to whether or not it's telling the truth or lying. Normally, multiplying by 3 makes the number bigger. Is this going to lie or tell the truth? It's going to tell the truth because it's a y. It's multiplying times the f, which represents y. So it's going to tell the truth. That's going to stretch this. So what would be shown on the test is vertical stretch by factor. Factor just means you're multiplying. It's right. It would shrink by a factor of 1/3. You take the reciprocal, you just flip it. Yep. It would shrink if it were inside. That's correct, because you do the opposite, it lies. Second one. Okay, anytime you add or subtract, it always shifts. But before we do that, is it inside or outside? Inside. So it's horizontal. The word that you'd be looking for is horizontal. Anytime you add or subtract, it's a shift. Inside lies, so it's not going -2 on the x-axis, it's going +2 on the x-axis. Which direction is that? Up, down, left, or right? Right 2 units. And finally, the last one, the +1. Inside or outside? Outside. So if it's outside, the V stands for vertical. If it's outside, it tells truth. And by the way, plus or minus, what does it always do? If you add or subtract, what does it do to the graph? It'll shift it or slide it. Yep. And so you're correct, Peyton. You're saying it's going to go up 1 on the y-axis. I agree. Up 1. And so that right there would be your bell ringer. Go for it. All right, chapter 2. As we start on chapter 2, the first thing we're going to look at today is power functions. So on your vocabulary chart, what I want you to note here, power function is anything that are functions that have only one term. Functions with only one term. It's a function with only one term. That's a power function. So let me give you 4 examples, and I want you to tell me which ones are power functions, which ones are not power functions. All right, out of those 4, how many do you think are power functions? 1, 2, 3, or 4? 3, 2, 1. 2 would be the correct answer. 2 power functions up there. By letter of equation, which 2 letters represent the power functions? F and G. These are my power functions because they're only one term. These are power functions. The others would be called polynomials. What does poly mean? More than one. They have more than one term. And so terms, I said a moment ago, factors means multiplying. Remember that when I said vertical stretch by factor 3, this means multiplying. Division and multiplication means factors. So this might have multiple factors if you think of that term, but we're talking about terms. How many terms are in the equation H? 2 terms. And how many terms are in I? 3 terms. So those are not power. Those would be polynomial functions because of that. So I just wanted you to get that first. Power functions means one term. Today, we're going to focus exclusively on power functions, and there's a reason for this. We're going to make a great, what's it called? Predictions in chapter 2 based off the equation. And specifically, we're going to look at the highest power. But before we do that, we need to know some of the rules that go on with that just one piece of a function. And so that's why we're dealing with power functions today, is for predictions, estimates moving forward. So when we deal with power functions, everything's simplified because it's only one term. To graph, you could graph all these on your own without a calculator. And today we're going to kind of go over this, just how to make predictions on graphs using 3 rules. So the 3 rules, I call them direction, shape, and the reflection. And then really what I'm talking about is the left side of the graph. So on the bottom of your packet, I know this is the very end of page 1, I would circle up these 2 slides and call this cheat sheet, because you're going to hear me say a lot today, cheat sheet. So at the very bottom, circle those 2 slides and write cheat sheet. It's going to really help you. The first slide deals with the right side of your graph. So you can really underline that in the first slide. That's the right side of the graph. The left side is the second slide. Number 3, it deals with the left side of your graph. And so I could read through these rules, but I think it's going to be easier to kind of walk you through step by step and just show you and then refer back to this cheat sheet. So I'm going to start here on example 1A. On yours, I simplified it to just say graph and analyze the equation. And so that's what I really want us to focus on, is to graph and analyze. And as we go through, I will throw out different things, but I'm going to kind of hide that for now, because all I want us to do here on example 1A is to graph and analyze. And on yours, I gave you a little X and Y, or a little coordinate grid. So here's how we're going to do this. Step 1 is going to deal with the direction of a graph. Step 1 is the direction. Now, how you determine the direction, is that how I call it, is you look at the A value. So this value in the front is your A. On this problem, A is 1/2. The question you ask yourself is 1/2 positive or negative? Is 1/2 positive or negative? Positive. So the way you symbolically write this, positive means it's greater than 0. I'm going to write that, and I'm going to say it's going to be in the first quadrant. So this direction, it's going to be in the first quadrant because A is greater than 0. So what I'm going to do is draw an X to the fourth quadrant. This graph will not be in the fourth. It'll be in the first because my graph is positive. That's rule 1. Rule 2, let me go ahead and do this. Rule 2 deals with what I call the shape. Each graph has one of 4 shapes, and it's all determined based off the power. The power here, they use the letter B, and so they'll say B equals 6. So when you look at the B value, the 4 shapes on the cheat sheet come down to one of 4 things. So you're looking at the B value. If your B is greater than 1, it curves towards the y-axis. If B is equal to 1, it's a straight line that's linear if your power is 1. If your P, and I usually skip this one, I'll say if B is negative, it's a C curve. But the one I'm kind of skip and throw in last is if your B is in between 0 and 1, meaning it's less than 1, but it's positive. It's going to curve towards the x-axis. So that's the 4 options. So now when I look at this problem, my B value is 6. And I'm going to ask you the question, is 6 greater than 1? Is 6 equal to 1? Is 6 negative? Or is 6 in between 0 and 1? It's greater than 1, which means it's going to curve towards the y-axis. Curve to or towards y-axis. And so what I want you to do is if it's a power function, as long as it's not a negative power, we're going to start at the origin, and this value should curve towards the y-axis like that. That's step 2. Step 3, when predicting a graph without a calculator, is you now look at the power to determine what's going to happen on the left side of the graph. So this is what I call the reflection. B equals 6. Is 6 an even number or an odd number? Okay, so remember from chapter 1, we talked about this, but it keeps coming out, so I didn't list as one of those 4 things. If it's even, does it reflect across the y-axis or does it reflect diagonally across the origin? Across the y. So now draw the left side, making ourselves have some type of parabola here. And there's your graph. That is so ugly. I wonder if I can. Well, shouldn't have been clicking. There we go. Clone. I'll make it perfect. Flip left and right. And I'm going to go change the color to green. There we go. And so now all of our pieces match up. And so that's how you go step by step on how to graph. And so here's their textbook graph. If you do it digitally, notice that mine's not perfect, but it's a great way of estimating what happens on the graph. Now I'm going to throw in each time we work the problem here, I'm going to analyze it in some type of way. On this type of problem, I'm going to talk about if it's increasing or decreasing on example 1. So as I trace this graph, if you follow my cursor here, as I trace it going from the left to the right, what's happening on the green portion? Is this increasing or decreasing on the green portion? It's decreasing. What's happening on the red portion? Increasing. And so the one analyzation I'm going to add for this problem is I would say it's decreasing from negative infinity to 0. And that's talking x values. Decreasing tells you it's going down. This tells you what x values it's going down from. The graph decreases from the left to 0. And then from 0 to the right, it increases. So 0 to infinity would be increasing. So that's just a little analyzation of this graph. It's going downward and then it's going upward. Now, that's really the whole thing we're going to do for most of today. I'm just going to reload and try something new and throw in a new twist each example. But it's basically those same 3 rules. Example 1b. Here's our new equation. And what I know the instructions say to do all these things. All we're going to do is first graph this and then analyze whether it's increasing or decreasing. Okay, so rule one, without looking at your cheat sheet, does anybody in here remember what rule one dealt with? The direction. Good, direction. You don't have to write out direction every time, but it goes off whether your A value is positive or negative. What is my A value on this problem? -1. I say -1 just because it's a negative, so -1. Is -1 greater than or less than 0? Which means what quadrant are we going to be in? The fourth quadrant. So where should we put our X this time? In the first quadrant. We know we're not going to graph in the first. If you close that, reopen it, might get it next time. Okay, second rule. What was the second rule? The shape. The shape is determined by the power. What is my power in this problem? Okay, so question. Is 5 greater than 1? Is 5 equal to 1? Is 5 negative? Or is 5 between 0 and 1? It's greater than 1. The cheat sheet says if the power is greater than 1, the power is greater than 1, it's going to curve to the y-axis. Curve towards y-axis. Now notice, because I'm in the fourth quadrant, that means it's going to curve downward. Like that. It's curving to the y-axis. The third step. What was the third step over? The reflection. What's happening on the left side of the graph? So it goes again off the power. Is 5 even or odd? Okay, what does that mean if it's odd? Is it reflects across the origin. So if I wanted to do this perfectly, I would take this, I need to clone it, and I would need to reflect it to go across the origin, which means diagonally. So I'm going to reflect it to the left and then reflect it up. And this would be my picture. And now once I make this green, so it's all coordinated, we got our picture. There is the graph. That's what it would look like. This time, if I traced it with my cursor, what's the green piece doing? Increasing or decreasing? Decreasing. What about the red? Decreasing. So it's decreasing always, or it's decreasing on its domain. So I'll say decreasing from -infinity to +infinity. Now I've done 2. What I'm going to do is give you a DOL, and I want you to try to, I know you can go to Desmos. Let's just get that out of the way. I know you can do that. I want you to first try to do this on your own, see what you come up with. DOL number 1. Walk through your 3 steps and try to draw a sketch of this to come up with your answer here. Let's now take a look at example 2. Example 2, we have the same information given. This time, what I'm going to add in is I will do limits. If you remember limits, I'm going to add in limits. So here's the graph that we're going to analyze. So example 2a, you already have this X and Y axis given to you. What is step 1 going to be for this problem? Step 1. The direction. And that is determined using which value? The A. What is our A on this problem? 2. Okay, is 2 greater than 0 or less than 0? Greater. So which quadrant are we going to be in? Which direction is it going to head off to? The first quadrant. So I'm just going to put, I didn't write the word direction this time, but it's going to be in the first quadrant, which means I can put an X to the fourth. What is rule 2? The shape. That goes off the power. What is my power this time? -4. Okay, so go back to the cheat sheet. You haven't seen this yet. The question I will be asking you is B greater than 1? Is it equal to 1? Is it negative, or is it in between 0 and 1? The answer is obviously it's negative. So what type of shape is it going to take if it's less than 0, meaning it's negative? A C curve. And you might be thinking, why do I call it a C curve? Well, I put C in parentheses because it's not a real name, but it's kind of like it's curving to both X and Y axis, but it doesn't go through the origin. So it's something kind of like this. That's what the C curve is going to look like. So there it is. That's what I call a C curve. I don't call it an L because it's not a point. It does curve, so that's why I call it a C. But it's not a general math name. You can call it whatever you want, but that's what I call it, C curve. And now finally, the third topic, or the third thing we need to find, is what we call reflection. Here my B is -4. Is that even or odd? It's even. And so if it's even, does it reflect across the y-axis or does it reflect across the origin? It's going to reflect across the y-axis. And so you will have a C curve that's reflected across the y. So clone, reflect across the y like that. There it is. On the last problem, we were talking increasing, decreasing. What is this green piece doing? Increasing or decreasing? Increasing. What's the red doing? Decreasing. Okay. But this problem, it's going to, on example 2, when we get there, it's going to ask about limits. So I want to remind you, a limit, the way I normally describe limits is that there's 2 limits for any piece. Any piece of graph normally will find 2 limits. And it's where the graphs, the bookends of each piece of graph. So these is where they're finding the limits. To kind of help you out, here in a second, I will type them in, or I will write them out as actual limits. That's this symbol. But before they do that, I'm going to write out where each arrow is heading off to. Where is this arrow heading to x-wise? Is it heading to, if it's going left forever? Negative infinity. Very good. Now for the y's, and this is really where the question comes down to, is it going up forever, down forever, or is it flat forever? So look over here. You're saying this piece right there is going up forever? It's not going down forever either. It's getting flat. And so you take it back to the y-axis and say, what y value is it getting flat at? 0. Answer is 0. And so that's the y value there. Now that we're kind of thinking along where I want you to think, let's do this limit over here. This one's going right forever. This arrow right there is going to the right forever. What x value is it approaching then? Positive infinity. What y value is it approaching? Is it going, and you can look at this graph, the digital one, is it going up forever, down forever, or is it flat? Flat. What y value is it approaching? 0. Take it to the y-axis, 0. So it's going to the y value 0. And so the end behavior would just be those 2 limits. You'd plug in those values. So if you're wondering, why do we not just write it in parentheses like that? Well, because infinity is not a real number. The graph doesn't actually get there. But a limit is like a prediction. You're predicting where it's going. And so you'd fill those in. The x's would be negative infinity, positive infinity. The y's on both would be 0. I'm going to go ahead and find these 2 limits in here, even though the DOL won't ask for it. Let's do the green arrow. That green arrow, and I don't know which one's more helpful to look at. What x value is this green arrow approaching if it's going straight upward? What's the x value if you took it down to the x-axis that it's approaching? 0. This is approaching the x value of 0. And the y value, since it's going up, what y value is it approaching? Positive infinity. Okay, and what about on this side? What x value is it approaching? 0. What y value? Okay, so that will make up our 4 limits. You may remember, however, that with functions, you cannot use the same x value twice. I have 0 used 2 times. Once for the green, once for the red. So we add a symbol in. A negative on the x means it's talking the left side. A plus on the x means it's on the right side. You would need to have those added in to be technically sound on our limits. So both the left side of the break and the right side of the break, the graph's going up to positive infinity. So there's just kind of a general review of limits. Let's look at 2b. 2b. Again, I'm going to kind of change my instructions here. take off all of this. So there's no way we get done finding all those every time. Let's look at this graph. Step 1, what's the first thing that we find? Which direction? Is it going up and to the right or down and to the right? And so you need to find your A value. What A value do I have this time? 2. Is 2 positive or negative? Positive. If it's positive, which quadrant is going to be located in? First quadrant. So it's not going to be in the fourth. I'll put an X there. What's the second thing we find? The shape. The shape's determined by the power. Our power is -3. Okay, so is -3 greater than 1, equal to 1, less than 0, or in between 0 and 1? Less than 0. Okay, if you need your cheat sheet, if your power is less than 1, meaning it's negative, what kind of shape is it? Here it's C curve. It's a C curve. So it'll look like that somewhat. Now we talk about number 3. What does number 3 find? Reflection. What's happening on the left side of the graph? If b equals -3, is that even or odd? Which means that it reflects across the y-axis or across the origin? Across the origin. So we should have something like this. There's our picture. If I'm going to do the limits, let's make sure we understand how the limits work again. You could write out this limit here 4 times because there's a total of 4 limits. Clone, there it is, clone. There are a total of 4 limits. Limit typically we'd find anytime the graph comes to an end. So since this graph has 2 pieces, there are 2 ends per piece. There's 4 total ends. 1, 2, 3, 4. So we'd have 4 limits. So you'd ask yourself the question, what X value is this arrow right here approaching if it's moving to the left? -infinity. And what Y value? And it might help to look at their picture. Is it going up forever, down forever, or is it flat? It's getting flat. What Y value is it getting flat on? 0. And so that would be one of them. You just plug it in as the X of -infinity, the Y of 0. This time I'm just going to go clockwise here. This arrow here, it's obviously going up forever. What about its X value? 0, you're right. And it's going up forever. Okay, I'm gonna plug this in. I'm gonna have to come back to it in a second. But for now, I'm gonna go ahead and write it in. The X is 0. The Y is infinity. That's this one. Okay, let's go to this next arrow. This one's going right forever. What X value is that? Positive infinity. What Y value is it approaching? 0. It's getting really flat, so it's 0. So we'll fill that one in. The Y is 0. The X is positive infinity. And now finally, this one right here. The X value it's approaching is 0, I agree. And it's going down, which means -infinity. Okay, so the one thing with functions is you're not allowed to have an X used twice. I have an X used twice. So what do we do to fix that? One's going to get a plus, one's going to get a minus. Just left piece, right piece. Since the green is on the left side, that one would get a negative symbol. Since the red is on the right side of the break, the right side is 0, it would just get a plus. It has nothing to do with this one happening to go up and this one going down. That is referred to in the Y portion. The X is all about, is it on the left or the right? And so that's how you would get that. All right, yours. I want you to try DOL number 2. The limits you'll be finding are what we call in behavior, what's happening in the far left and far right. So these two limits are the ones you will find on the next problem, the ones that go far left and far right. But before you do that, you need to graph it first. So please go ahead and try DOL number 3. Try to graph this, see what you come up with, and then get your limits from there. All right, let's take a look at example 3. Example 3 is where this can get tricky. So you need to really lock in on this part. You might be thinking, I got this totally down. That's great. Where example 3 gets tricky is that sometimes you won't have a left side of the graph and sometimes you will. There's not every case will have a left side of the graph. So let's talk about that. It happens when you have a fraction power or a root. Shown on this slide, it shows them as roots. If you have a root, you might or might not have a left side. So let me walk you through the steps. Step 1, just like before, and let me cover up some stuff here again. Step 1 has to deal with what? Direction. So what you would look at is this first quadrant or fourth quadrant based off your A value? What is your A value if it doesn't show a number? 1. A is 1. Is that positive or negative? So which quadrant are we going to be in? First. So I'm going to go ahead and put an X in the fourth quadrant. That's not how you spell quadrant. So there's my X. Step 2 deals with shape. What is my power on this problem? 5, 4. So this is the first time we really had to think about this. 5 is bigger than 4. So does that mean it's bigger than 1 or less than 1? It's bigger than 1. It's obviously positive, but it's bigger than 1. So according to the cheat sheet, if your power is bigger than 1, which way does it curve? Curve towards the y-axis. Okay, so now starting from the origin, if the power is positive, it'll start at the origin. We curve it towards the y-axis like that. So here's rule number 3. When you talk about the reflection, and this is where I really need you to pay attention. So phones, Angel, keep those devices put away. Here, the left side, with a fraction, you have to look at the denominator first. Mark acts like he's already seen the videos or something. You look at the denominator first. If the denominator is even, then you will not exist on the left side. You see how this has a power of 4? If your denominator is even, then it will not exist. Graph does not exist on the left side. Does not exist. So the left side of the graph will not exist. I'll put D, N, E. And so that is my graph right there. On this time, I'm going to talk about the domain here. The domain on this picture, looking at the picture, so I'm not paying attention to the algebra here. The domain on the picture, is it all reals? No, from where does it start? 0. So I could do a closed dot if you wanted me to. It goes from 0 until where? Positive infinity. Okay, so if you're now thinking, how does that tie in with what we've learned? A division of power that's dividing, like, or as a fraction, that means divide by power 4. This could be written as the 4th root of x to the 5th. Any even power follows the square root domain rule. So I've been saying a square root, any radical that has radical is another name for a root. Any radical that has an even power or even radical follows a square root that it has to be greater than or equal to 0. Since there's no transformation, it stays at 0. That's the domain. So it's continuous from 0 on. Let's try part B. Let's see this one more time. Part B, again, they give us all these extra information. I'm just going to focus on domain this problem. So there's the equation. And if you're wondering, why do I not have a computer generated graph this time? It's because the textbook has the wrong graph here. They didn't do it correctly. Had a typo. Here's the x-axis, here's the y-axis. All right, what's step 1? What do we look for first? Direction. Is it positive or negative? This one, a equals 4, greater than 0. It's positive. Which quadrant is going to be in? First. So I'll put an X through the fourth quadrant. Step 2, what's my power? Good, you are catching on what's important. It's negative. It's less than 0. So if you cheat sheet it, if it's a negative power, it's a C curve. All right, so I have a C curve. Now for rule 3, what does rule 3 deal with? The reflection. Your power, you first look at the denominator. This denominator is odd. If the denominator is odd, it will exist, graph will exist. Did I say does not exist last time? Okay, let me just say exists. If the denominator is odd, there will be a left side. The numerator will then tell you if it's even or odd. Since it exists, what's 2? 2 is even or odd? So B equals -2/5. -2/5 is even. You go off the numerator. And so if it's even, how does it reflect? Across the y-axis. And so your graph would look like this. Tell me about the domain this time. It goes from negative infinity to positive infinity. Any breaks in there? Yes. At 0, the domain would be from negative infinity to 0, union from 0 to infinity. Because I use parentheses, that means all reals except for 0. It does not include it. It means there's a break there. Or you could write it as x does not equal 0. That's how I was writing it earlier this school year. I was writing it like that often. If you're going, why is that the case? Well, this problem could be rewritten. What you'll learn is a negative power means just put the x in the denominator. It really means that you're dividing by x to the power of 2/5. So now we're dividing by the x, and that's why it has that break at 0. But you could also rewrite that as 4 over the second root, no, sorry, 5th root, not the square root, 5th root of x squared. That's another way of writing that problem. All 3 ways that they're true. So a negative power just means the x goes to the denominator. That's all it means. And division part of the fraction is the root. So it's a 5th root or a 5th radical. Okay, your turn. I want you, and I know you can try check this in Desmos, totally aware of that. I want you to try to do this problem and then find out, tell me about the domain. So DUL number 3 here. All right, now we're going to talk about regressions and models, some of the favorite things for statistic-minded students. So here we have a problem. It says the following data represents the body length L in centimeters and the mass M in kilograms of several African golden cats being studied by scientists. Create a scatter plot for the data. So I'm going to walk you through, some of you in the past maybe learned how to do lists and spreadsheets on TI Inspire. What I'm going to show you is how on my Desmos, how to come up with a scatter plot and to represent this data. So here's what I want you to do. If you have open this 2-1 folder, I want you to right click on the pre-programmed graphs. If you're on your cell phone, just hold down on the button, just hold it down until it asks you what you want to do. And I want you to click open in a new tab. So on a computer, it's real easy. Just right click, open in a new tab. On the list of pre-programmed graphs, this is graph number 6. So these are ones that we've covered already, 1 through 5. This is graph number 6. It's dealing with regressions and models. Regression is the technical math term. Applications, we usually call it a model. So that's why I put regressions and models. Statistics, people would call it a model. The actual math name is a regression. What that means is we're given data and we want to come up with an equation. So I've clicked that. And now I'm going to type in this data. What I'm going to do is I'm going to treat the L as my independent X variable. So that's my X is going to equal L. My Y's are going to be the M's. This is a second list of X's, so this will just be X's continued. These are my X's continued, and these will be my Y's continued. So now, I would love it if you follow along here and have this open on Desmos. Again, I showed you just right-click it from your lesson exam, the Desmos pre-programmed graphs. From the list, choose number 6. Otherwise, you have to know how to program it to do a list in spreadsheets, and that's hard to do. So I'd rather you just click my link and open it up. I'm going to go through and type in this data. So I'm typing in all my links right now, which I'm treating as the independent X's. So I have all my links typed in, and now I'm going to do the masses, the M's as the Y's. I have mine typed in. What you'll notice after you type yours in is that on the bottom left of the table, there is a magnifying glass with a plus. If you click that, it'll change your data from looking how mine does currently to where it zooms in and gives you that scatter plot. So again, what I just clicked is after I typed in my data, is I click this magnifying glass with a plus. So I'm going to click that now. So it zooms in on my scatter plot. So part A, and I know I might be going fast, but I'm just going to keep talking. I'm giving you time to type it in while I talk. Part A just wants a scatter plot. There's my scatter plot right there. So I've now done my scatter plot. You know what I'm going to do here? So I'm going to now move this over so you can see it. Okay, so there's my scatter plot. That's part A. Now, hopefully that was enough time to get at least quite a few of their values in. As long as you've got quite a few in, you'll be able to do the math here. Part B says, determine a power function. And let me try to clear this up because there's a lot of words up here. Determine a power function to model this data. And so here's how you do that. On the left side, I have programmed these to find all types of different equations. What you're going to do is on the left side, scroll down. What I automatically have hit is quadratic. This isn't quadratic. We're looking for power. So I'm going to close that folder. I'm going to look down for the arrow or folder for power. And I'm going to click that little button there to light it up. So there's my model. That's a power function. And the equation is given down here. It shows you what the equation starts out of is y equals ax to the power of b. And it tells me what my a and b are right there. And so I'm going to write those down. Let me slide this over. Actually, I'll just copy and paste it. Make it easier on your notes to know later where I looked. And so now these are my values here and I can write my equation. So part B, what you would do is you would write your equation as y equals the a value, 0.1769. I've missed a 0.1769 x to the power of 1.53764. I did 5 decimals on both. I think that's to the 10,000th right there. That would be my equation for part B. And the end behavior, it's going up and to the right. If you wanted to write that down, you just say, basically what this is saying, I guess since I use a y, I need to use a y here. As the length increases, the mass also increases. That's the idea. And that kind of makes sense. The animal gets bigger and bigger. You'd assume the mass, longer and longer, you would assume the mass also gets larger and larger. And now part C. Part C wants us to use that equation. And it says to predict Let me cover this up so you can see just the important part. It says predict, or the scatter plot to predict the mass of an African golden cat with a length of 77 centimeters. I'm just going to use that equation we just came up with. That equation was 0.01769, I think. 1769, yep. X to the power of 1.53764. And what I'm going to do is plug in, since the length is 77, the length was the domain. I'm just going to plug in a 77 right there and for X. So I'll do that on new line here. 0.01769 times 77 to the power 1.53764. And that's how I'd get my answer there. So the mass is roughly 14.07575 kilograms, to keep it 5 decimal places. And that would be my answer. Now I have a DOL for you. I want you to use that same graph. You can just hit the refresh button, clear it all, to graph this and come up with your answer. All right, now let's take a look at example 5 here. It says graph and analyze 5 times square root of 2x to the third power. Describe the domain, range, intercept behavior, all that stuff. Yeah, we're going to take a look at that. Specifically, this time we're going to look at intercepts. So I'm going to cover up all this, and we will look at intercepts here in a moment. And so now we have a few different things going on. So if I'm going to follow my rules, it's a little bit tricky on how this is one term, and I'm going to show you rewriting this. You could rewrite this as 5 times the parentheses 2x. Now this is square root means divide by the power of 2, so it'd be the power of 3 halves. So it is one term, but it's a little bit tricky in the sense that truthfully the a value is not 5, it's actually 5 times 2 to the 3 halves power. Okay, so my a term is 5 times 2 to the 3 halves power. But that is still greater than 1. Either way, we know that's positive. It's not negative, which means it's going to be in the first quadrant. This is rule 1 here. First quadrant. So here's my y-axis, my x-axis. We know it's not down there. Second rule, the power. The power is 3 halves. Now that power is greater than 1. So anytime the power is greater than 1, it's going to curve towards the y-axis. Curve towards the y-axis. Which means it'll curve this way. And now rule 3, you talk about the reflection. What's going to happen on the left side? Since my power is 3 halves, since the denominator is even, the graph will not exist on the left side. Since the denominator is even, it does not exist. Does not exist on the left side. Exist, which you might see abbreviated DNE. So this would be the picture of the graph right there. It would look like that. Now, what I told you we were going to look at is intercepts. And on this problem, both the x and y intercepts are just at 0. So the x-intercept and the y-intercept is at 0 because this hits the origin 0, 0. Anytime your power is positive, by the way, anytime your power is positive on the power function, it'll hit the origin. So now let's look at part B. This time, this is no longer one term. This is now multiple terms. So technically, it wouldn't follow the same rules, or there would be more to it. So this would actually have a shift, a transformation attached. But if I went through my rules trying to use the same 3 rules, first off, the rule 1 would say, are we positive or negative? On this problem, the a is 1/2. So it is positive. It's greater than 0, so it'll be in the first quadrant. So it's not in the fourth. And the second rule that we would look at is dealing with the power. So let me erase some of this so that we can really see more what's going on. There we go. Or move that to front. There we go. And so now when I look at my power, that's a fifth root, and the x itself has a power 1 inside. So this is like saying the same thing as 1/2 times the parentheses 3x minus 4 to the power of, since it's a 1/5. Because you're dividing by a power of 5. So it's like to the power of 1/5 there. All right, so with that, my power is 1/5. Now, 1/5 is, this is a weird one because it's greater than 0, but it's less than 1. So this is, let me put it this way, it's greater than 0, but it's less than 1. So this is the first time we've seen it. According to rule 2 about the shape, if your value is, your b is in between 0 and 1, it's going to curve towards the x-axis. Curve towards x-axis. So this one will actually curve this way. Because the power is positive, it does hit the origin. And now rule 3, talking about the reflection. If b is 1/5, you'd first look at the denominator, and this denominator is odd. So it will exist on the left side, it will reflect. And since the 1 in the numerator is odd, that's what this will be, as an odd function. So the denominator tells you whether or not it exists. The numerator tells you if it's even or odd. This is odd, so it reflects across the origin. So I need a, origin is diagonal. And so if I were going to do this properly, I would need this to curve this way across the origin. So it's going to curve towards the x-axis in the third quadrant. And again, the x and y intercepts would be the same thing. 0 and 0. Now that's what it appears on the get-go. The problem is, this problem, it would actually be shifted because of this transformation. And so it starts there, but it's not going to end there. This one here, it has a shift. If you set this 3x minus 4, I'm just walking through transformations here. You set it equal to 0, it's easier to solve. You would add 4 to both sides. So I'm trying to determine where the center of this graph is and what I'm doing. I'm taking the inside. I know this is going to shift right, and you would think right 4, but this is also horizontally shrunk because the inside lies. And so we add 4, so we add 3x plus 4. So at this stage, it looks like it shifted right 4, but then comes this step where you need to divide by 3, which means it's actually shifted right to 4/3. So this graph would be shifted right to wherever 4/3 is. Wherever 4/3 is, that's where this graph is shifted towards. So this graph would actually look different. It'd be right there and right there if it's drawn correctly. So you can see that there's the actual picture. You can see there's a little bit more going on in the graph because of all of that. But now we know that it actually crosses the y-axis at a different number and the x-axis at a different number. Since those are different, I'm just going to erase those, and we need to go to Desmos at this stage to figure out what is my true answer here. So let me erase this 0, 0. We'll go to the graph and determine. I'm just going to get a blank graph here. I'm going to delete the crazy letters. So it's just Desmos calculator. And we will graph this to see where are my actual intercepts. And so this is not the square root, this is the fifth root. So I need to go to the Desmos keyboard, functions, hit miscellaneous, and there it is, in root, like that. 5 to 3x minus 4, whoops, minus 4. And you can see the y-intercept and the x-intercept are given. So it looks like the x-intercept, well, we did have that one, that was 4/3. That's what 1.333 is. We knew it was going to be 4/3 there. So I should have written that one down. But the y-intercept, that's the one we did not necessarily know right away. And it looks like it's -2/3. Well, that should be rounding to a 0.67 if it's going to be 2/3. So I'll just say a -0.66. I think it should, I don't know. Maybe it's not 2/3, but that's what it's coming out is right there. So now I have DOL number 5. You can graph this and find the intercepts. That's what I'd recommend you do here. Just go ahead and graph it and find what the intercepts are. Desmos will give you decimals, but one thing you can do is if you know the ones that you know by hand, like off the top of your head, for example, 1/2 is the same thing as 0.5. This would be plus or minus 0.5. If you go through writing down the values that you know, you should be able to eliminate some of these. Yeah, those are the ones you know. So just off of this, I'm looking at the X, there's 4 different options. So if you just figure out which X-intercept is true, you'll have your correct answer. It's either only a positive and a negative crazy decimal, it's only a positive 1/2, or it's plus or minus positive, plus or minus 0.5. All right, example 6, if you're going to solve. So how do we solve some? This is where we kind of get away from power functions, and now we're just kind of going through the math. I just want to make sure you know how to solve this. I'm going to try to solve this. I'm going to get rid of the radical. The radical is the hard part in here. So I'll add 3 to both sides. So I have 2x plus 3 equals the square root of 28x plus 29. And the way to solve when you have a square root is you square. The thing about a square, though, is it squares the entire side of the equation. So I should have a squared over here. Now, if I want to ultimately solve this correctly, I need to FOIL this out, or box method, whatever you want to do. And so foiling means if you write it out itself, 2x plus 3 times 2x plus 3 here, that's a squared. I would just totally multiply that out here. This is 28x plus 29. So when I multiply this, the FOIL, that's the first times first, or no, the FOIL, that's the F, first times first. 2x times 2x is 4x squared. And then comes the O, which would be the outside times the outside. So the outside times the outside. 2x times 3 is 6x. Then comes the I, the inside times the inside. 3 times 2x is another 6x. And then finally, last times last. 3 times 3, the last times the last, is 9. This would equal 28x plus 29. And now from here to solve, you just combine your like terms. So I see on the right side, I have this 28x. I'm going to subtract the 28x from these 20 over here. So I'll have those terms combining. And I'm also going to subtract 29 from here, 29. And so now, let's see, I'll have 4x squared. 6x plus 6x is 12x. Minus 28x is minus 16x, if I did my math right. And then I have a plus 9, but a minus 29 is minus 20. All that equals 0. To make this problem easier to solve, I could just divide everything by 4 because it's GCF here. And you don't even have to factor it out since it's set equal to 0. You can just divide both sides by 4. That makes my problem a whole lot easier. So what I'm left with is x squared minus 4x minus 5 equals 0. That is that's in the form of ax squared plus bx plus c equals 0. And we can do x method factoring for this. Remember, with x method, you take your a times c and your b in the bottom. So a times c, that's a 1 times -5. 1 times -5 is -5. So I'm looking for factors of -5 that add up to the b value of -4. And when we went over this earlier this year, we had 2 letters, and I gave you a little t-chart to kind of help you out if you struggle with coming up with numbers. The only factors of 5 are 1 and 5. So this one's really easy. I got to get a -4. So the way to get a -4 is 1 minus 5. That's going to be my numbers, 1 minus 5. And after we did this, what we did was we split our a power. So I'm going to split this a power. So instead of being 1x squared, it's just going to be 1x and 1x. So I split that power, and then you put in the side numbers, plus 1, minus 5. All that has to equal 0. So we just factored this right here. That is in standard form. This is in factored form. Of according to the zero product property. So the zero product property states that if you're multiplying, you have a product of 0, one of these factors has to equal 0. So either x plus 1 has to equal 0 or x minus 5 has to equal 0. And you would just subtract 1 over here to solve. So we find out that x equals -1, or here I would add 5. And I find out that x equals 5. So these would be our two answers. You would technically need to check them by plugging them in to make sure it works. But at this stage, I'm going to just show you, I have a calculator for this. It's called InSolve. So I'm going to come back to my list here. I'm going to click this InSolve. And this will give us our exact answers. And it's a lot faster. Watch this. 2x equals. Okay, this is going to equal, what happened here? The square root of 28x plus 29 minus 3. And so after you graph these, it says on here, secondly, graph y equals the left side, so y equals 2x, and then y equals the right side. I put that here. And I don't know why this is freezing up on me. So I just pasted it. The answers are going to be the intersections. So you can see that they intersect the x equals -1, that's that answer, and also x equals 5. So that is a lot quicker way of coming up with our solutions here. And so if you wanted to try again, this time I'll do Desmos first. 12 equals, it's the third root, so I need to go to my functions, miscellaneous tab, and hit the n for the nth root. 3 times, and here x minus 2 squared, and then plus 8 on the outside. Again, if you copy down the equations, y equals the left, y equals the right, the intersections should be the answers, which here would be -6 and 10. So the answers to this problem are going to be -6 and 10, and I'll prove it to you with the algebra now. If you want to see the algebra, I would try to isolate this x. So I'm going to subtract 8 to begin the problem. And so I'll have 4 equals the third root of x minus 2 quantity squared, which is the same thing as another way of writing this is x minus 2 to the power of 2/3, 2 divided by 3. And so if I want to get rid of the power of 2/3, you need to raise everything to the power of 3/2. So what I'm going to do here is raise everything to the power of 3/2, which right here, it's the same thing in the middle. You don't need the middle section here any longer. So 4 to the 3/2. So the square root of 4, that's, or you could think of 4 cubed, 4 times 4 times 4. Would be 16 times 4 is 84, and then you take the square root of 64, which is going to be 8. That's going to be the number where you get there. But in case you don't know, I'll just prove it over here. 4 to the power of 3/2 is 8. So what mathematically what just happened there is you take 4 times 4 times 4. That's 4 cubed is 64, and then you take the square root of that, and so we got the number 8. So I'll simplify and say 8 equals, and then over here, these cancel one another out, or you could look at these canceling one another out. So you're just left with x minus 2. And you add the 2 to both sides, and there's the answer of 10. Now you might be thinking, where did that other answer come from? Well, it comes from this. Anytime you add a square root, so when you add a power of 2, you need to add a plus or minus. So over here, I need to have a plus or minus, which means it's plus or minus 8. And so technically this would have two answers. There's the positive 8. You would also need to do the minus 8 equals x minus 2. And so this time when we would add 2, you get the -6. Now, why do I want to show you the calculator first? Because the calculator gave us both answers, and it was a lot easier to see both answers. There's less likely that I would screw up and forgetting the plus or minus or whatever else. So that's just a good way using Desmos to get your solutions. So now there's one more. I'm just going to allow you, you can go through and use your calculator for that one. And then again, use your calculator for this answer. Let's take a look at some DOLs or some practice sketches. You can do this on your own. Just some practice here. I'm going to take a look at the spiral review problem, your ACP problem. If you had to find the inverse, and I'm going to stay on the calculator theme because we did algebra already, you would switch your X and Y. But I want to remind you that there is a calculator for this, for inverses. If you're given equations, multiple choice. And so what you would do is you first graph the actual equation here. So 3x minus 1 over 2x plus 3. And it says in here, the original function will appear red. So the red's the original. The blue is the inverse. And I can see the blue is broken at a positive value. It looks like it's somewhere in between 0 and 2, and it's not 1. So about 1.5. I can tell the graph is broken. So when I look at my answer choices, I don't even have to type all these in. I can tell that the graph here breaks when x is like 1.5. So I'm going to eliminate a couple of these two in particular, because that's saying negative 1.5. This breaks at positive 1.5. Now I just need to determine which one of these two equations is accurate. Is the equation 3x minus 1 divided by 2x plus 3? And that just covered up the original, but I'm looking for the blue. So it's not going to be that one. It must be this one. Let's check this one out. Negative 3x minus 1 over 2x minus 3. Notice this graph highlights the inverse. So that is the correct answer here. The answer is G, not H.